Okay, so remember that if we have a scale in certain units and we want to convert that to a z-scale, which is unitless, right? Then we can use this equation, c equals x minus x bar over s, to go in this direction. But now if we want to go back in the other direction, we need to use the inverse function, x equals x bar plus cs, in order to go back. So far, we've been doing examples of, units of donuts or exam percentages, right? And using this equation and converting that into a z-score, right? So this would be a z-score. But now what we're going to do is we're going to take z-scores now, which are unitless, use this inverse function to take them back into the scale that actually has units in it. Okay, so that's what we're doing now in this think, pair, share. So you should give this a try yourself and then come back and watch the rest of this video to see my solution to it. All right, so let's take a look. So convert a z-score back into sample data scale. This is dealing with coffee. So a random survey of 13 office workers was conducted, which asked how many days out of a 30-day period at least 1 cup of coffee was consumed. The study produced the following figure of the z-scores of the sample data. Okay, so notice the sample data we're looking at is in z-scores versus frequency. Now, what's making this graph a little bit difficult to read is you'll notice that, these points aren't exactly on a tick mark. Okay, they're a little off. But that's okay because I've provided, a table of z-scores here and the frequency of each z-score. So you can see this z-score, which is the highest negative value, negative 1.3125. So negative 1.3, there was one of those. So here's 1.25. So 1.3 is right about here, and there's one of those. Okay, so that's this data point. The next one, where there's a frequency of 5, okay, that's z-score with a frequency of 5 is negative 0.6875. So right here is negative 0.5. So yeah, and this is negative 0.75. So this is negative 0.6875. And then here we've got this number, which is slightly negative, negative 0.06325. There's 3 of those. So here's those 3 right here. So it's just slightly negative, just close to 0. And then the other 4 data points are above 0, and those should be positive numbers. So we have positive 0.5625. There's 2 of those, right? That would be this one. And then there should be one that's above 1. There's one of those. So here's that one, 1.2. There's one of those. And then another one at around 2.4. Yeah, right there. All right, so this dot plot, the actual data values are represented here in this table. And what we want to do is we want to convert these z-score values into a data set composed of units of cups of coffee. So the units will be cups, okay? So what we need to do is we're going to take our unitless scores, which are z-scores, and convert them into cups of coffee in this case. And so we need to use this equation, which is the equation that I've put right down here. Okay. And so what we're going to do is when we convert this to cups, we are going to scale, Okay, we're going to put the scale in here on this horizontal axis, and we're going to graph our data based off of units of cups of coffee consumed. Or no, not cups. This is days. I'm sorry. Right? So if they drank one or more cups in a day, then that counted a day they had coffee. I'm sorry. So yeah, we're talking about units of days here that coffee was consumed in a 30-day period. That's right. Okay. Authors of the study also reported the mean of the sample data was 15.1. So the sample mean was 15.1 and the standard deviation 1.6. So the sample standard deviation is 1.6. Reconstruct the sample data, which is the number of days out of 30 which coffee was consumed, from the Z-score data provided above. All right, so what you could do is use this equation and do it manually, one at a time. Okay, so what we're trying to get is we're trying to get this value of x, which is going to be our converted value, which is the number of days that coffee was consumed. That's our output. And this z-score here, this is our input. And so what we need is x bar and s. And x bar and s is what was given to us. So we have everything we need. These input values are these values here in the table. We need this table because we can't get accurate enough numbers just by looking at the graph. Okay. So let's maybe do one of these by hand to see kind of how you would use this formula. So we're going to be looking for the value of x, where the z-score is negative 1.3125. Okay, and that's going to be equal to x bar plus z-s. All right, x bar is 15.1. Our z-score is negative 1.3125. And our standard deviation is 1.6. So all I did was substitute these values in. To the right-hand side of the expression there. Okay, so now we just need to simplify this expression. So calculators are handy for that. Yeah, so let's do that. So I'm going to use the NumWorks calculator for this one. So we're going to have 15.1 plus, and let's see here, that was a negative 1.3125 times 1.6. All right, let's see if this works. Kind of curious. Okay, it did. So that comes out to 13. All right, so x, when z is equal to negative 1.3125, that's equal to 13. So here I'm going to put this in the table. That's 13. So let me put one point with or a point at 13. Oh, well, we'll wait to graph it until we get them all. Okay, yeah, we need to do that. All right. The next one is going to be x when z is equal to negative 0.6875. Okay, and we're using x bar plus z s. X bar is 15.1 plus z, which is a negative 0.6875, and s, which is 1.6. Again, substituting, substituting, substituting. I don't know why I did it with my mouse just there. All right. Now let's do this on the Texas Instruments calculator this time. Okay, so we've got 15.1 plus. Now, a common mistake that Texas Instruments calculator users do is instead of using a negative down here, they put a minus. Okay, so we want to make sure that we use negative to represent a negative number. See that very often. Okay, 1.6. All right, so hit enter, and we get 14. So x when z is equal to negative 0.6875 is 14. There we go. All right, let's do another one. So we have this one, which is also negative. So x when z is negative 0.0625 is equal to x bar plus zs. X bar is 15.1. Our z value is 0.0625 and s is 1.6. Again, substitute, substitute, substitute. All right, let's calculate that one out. So we've got 15.1 plus. The NumWorks calculator doesn't have like a dedicated negative button, so this one you just use minus 0.0625 times 1.6. Okay, we get 15 on that one. Okay, so the value of x in units of days when our z value is negative 0.0625 is 15. All right. So let's look and see if this is making sense so far. Because notice that these z values are negative, right? And these z values are positive. So right here in the middle, this is where our z-score of 0 is, right? Below z, we have negative values. Above z, we have positive values. And that means that right at this point, that is where our sample mean should be. And so what was our sample mean? It was 15.1. Oops. All right, so that makes sense, right? Because if this line right here is 15.1, 15 is less than 15.1, so we would expect that to be here, right? Because that's where we have negative z-scores. So this next value should be greater than 15.1. All right, so let's do that one. So I've got x z when z is a positive 0.5625. Okay, that's going to be equal to x bar plus zs. X bar is 15.1 plus our value of z, which is positive 0.5625 times 1.6. Okay, so we need 15.1 plus, okay, I don't need to put a positive there, 0.5625 times. So if we're doing this right, we should get a value greater than 15.1. Yep, we got 16. There we go. Okay, so the value of x in units of days, should probably be putting days in there, is positive, when z is positive 5625, is 16 days. Let me go back and put these units in here because I think that helps to reinforce that we're converting a unitless z-score back into a value with units. Okay. All right. So let's use the calculator maybe to get these last two. You know, um, I've been able to, show how you calculate it manually. So hopefully you practice that. I really think it helps your brain absorb this idea. But let's go ahead and use the calculator. So here, if we go to the list editor, you can see I already put in the z-scores with the frequencies here. And what we need to do is program L3. Now we need X bar and S. So actually what I have to do is I have to run one variable stats first. Because if I don't run one variable stats first, the Texas Instruments calculator will not put the new value of X bar and S into the calculator memory, right? It hasn't been calculated yet. So let's do that first. So we'll hit stat, edit, or no, calc, one variable stats. Okay, my list of unique datums is in list one. Those are my z-scores. And then the frequency of those z-scores was in list two. Okay, now the calculator has updated this variable x bar in its memory, and it's updated the sample standard deviation in its memory. Okay, so now when we refer to these two variables, when we use our equation, it'll be the correct values. Okay, so let's go ahead and quit out of this, and let's go to stat, edit. Okay, we're going to program list three. So list three is we're going to put this formula in x bar plus zs. So we need to put in, okay, so make sure that list three is selected here at the top and it says L3 down here at the bottom, And so we need X bar. So variables. Now we want statistics, and that's option 5. So we can just click 5 on the keypad and it'll go straight there. And then we want X bar. Okay. And then that's going to be plus our z-score, which is list 1. So second and 1, that'll put list 1, times the standard deviation. And that's a variable again. So I'll hit vars. I'll hit 5 for statistics. And then I could hit 3. Okay. But I'm just going to scroll down and do that. So let me hit enter. There we go. And wait a minute. That doesn't look right. That, of course, is not right. That should have worked. X bar plus list 1 X. X bar plus list 1 times S. Okay, let's double check our values. So let me quit out of this. So a little bit of troubleshooting here. I'm going to go to variables, statistics, X bar. Where did I get that from? That shouldn't be there. Okay, this is instructive because here we're troubleshooting what the problem was. This should have been, oh, it's not going to be 15.1. That's what I did wrong. We were told what the mean and standard deviation was. Okay, so oh my goodness. All right, so embarrassing. Let me go to stat. Hopefully you're screaming at me from your computer screen going, no, Dr. Morales, you're doing it wrong. All right, so I was thinking of the previous example. All right, so our X bar we were told to us, that's 15.1. Okay, I apologize. And then list one is our Z-scores. And then our standard deviation was 1.6. Yeah, it's right here. So now if I hit enter, look at that. 13, 14, 15, 16, and 17 and 19. So what we need to put in here is 17 and 19. Okay, now to do the same thing with the NumWorks calculator, let me go back home, go to the statistics app. So I put in the Z-scores, I put in the frequency, and now I want to program into this column V2, the same formula I've been using. So let me hit OK, fill with a formula, just make it empty. Okay, X bar, I said it was 15.1 plus. These are our Z-scores. So I'm going to put in V1. So to put a capital V, which is right here, I need to hit Shift, Alpha, and divide. So V1 times our standard deviation, which was 1.6. Execute. 13, 14, 15, 16, 17, 19. Look at that. Okay. So let's go ahead and graph those. Okay. So we've got 1 at 13. Oh, but we got to figure out how we're going to plot it. All right, so our minimum value is 13 and our maximum value is 19. So let's maybe start our axis at 12 and then we'll end it at 20, if we can do that. So let's start here at 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I think we'll be okay if we stop there. All right, so we need 1 point at 13. We need 5 points at 14. So 1, 2, 3, 4, and 5 should be right there. Okay. 3 points at 15. So 1, 2, 3. 2 points at 16. So 1, 2. 1 point at 17. And 1 point at 19. Okay. Now, if we've done this correctly, then the shape of our data here should be the exact same shape of our data up here. And it is. So here we've converted our data from being in a Z-score to being in units of days that coffee was consumed. Now let's take a moment here to kind of reflect back on our previous section. We did measures of center. Okay. So 15.1, that was our sample mean, right? And our mode is going to be right here. Remember, the mode is the value that occurs with the highest frequency. And so our mode is 14. Now notice that the mode and the median, the mode and the mean are not sitting on top of each other. And the mean is being pulled to the right. You know, the mean is being pulled to the right because this distribution is skewed to the right. It's skewed to positive values. So this relationship, so what we've got is we've got a right skewed distribution, which means that the mode is going to be the smallest value. The next smallest value will be the median. And then the largest value should be the mean. So the median should be somewhere between 14 and 15.1. And let's do, like a quick, like one variable stats and just calculate the median just to see if we're right. Okay, let's do that really quick. Let me copy these values over from this column to this one. So I'm going to fill with a formula, empty, and let me put N1. So Shift Alpha N1. And let me see what the median is for V2 and N2. So I'm going to go up to the Stats tab. And the median is 15. The median is 15. So if we come back over here, so the median is right here. The median is 15. 15 is between 14 and 15.1. So the mode was 14, the median was 15, and I think I need more coffee. This should be the mean. And the mean was 15.1. Okay, so that was a little retrospect there, a little recall. But the main point of this, was to take values that are z-scores, convert them back to some kind of unit that these datums originally were represented by, and to show this relationship of going in both directions using both equations, which are inverses of each other, and show you how to do that on the calculator as well. All right, let me know if you have any questions.